Welcome to channel Qtomation. So far in our previous sessions we have seen about different locator strategies to use in automation. We have seen standard locators like ID, name, link text, partial link text, class name and tag name. And we have also seen the practical examples of how to use such standard locators to locate any element in Selenium. We have also seen customized locators like CSS selector. In CSS selector we have seen how to use combination of tag and ID, tag and class, tag and attribute, tag, class and attribute. After that we have also seen the examples of XPATH as well. We have seen absolute XPATH and relative XPATH. How to write absolute XPath, how to write relative XPath to find the element that we have seen. After that we have also seen how to write dynamic XPath using XPath functions like contains, starts with, text function. We have also seen XPath using OR and operators. We have also seen XPath by using OR and AND operators to write a dynamic XPath. Now continuing that, we are going to see one more topic, that is XPath access. So what exactly are XPath access? XPath access are also very useful to find out web element present on our HTML page. So XPath access are a way to navigate and select elements in XML or HTML document using a specific relationship with other elements. So by using XPath access, we can find out specific web element on the web page by using its relationship with some other element. They help you find elements based on their position or association with other elements. So we can take context of some another element to find out our targeted element. So if on the web page, if we have the element whose location is very known and we want to find out the target element which is nearby to that context element, then by using the context of that context node or context web element, we can find out our targeted element. So think of XPath access as different directions or perspective you can search to find out the element. We can use that to find out the element using XPath access keyword. So basically XPath access are nothing but keywords. There are some set of keywords that we can use within the XPath, and by using that we can navigate in DOM structure using context of some specific element. So we know in HTML DOM structure we can traverse top to bottom or bottom to top with the context of that specific element. So if you know the context of some specific node, then by using its relation with another node, we can find out our targeted web element. If our target element do not have any unique attribute, so when XPath access are very useful is if our target elements do not have any unique attributes or static inner HTML, then we need to locate the elements with respective to element who has an unchanging path. So if our target element which we want to find out do not have any unique attribute, or it is also not having any static inner text, then we have to locate that element with respect to some another element who has unchanging XPath. We do this very well in our real life as well. We always give direction to unknown location with respect to a well-known location or a landmark. For example, whenever giving direction to your home from a well-known shop, statue or railway station, etc. So we always give address like behind the theater or near that shop, specific shop. So we know the location of the shop. So by using the context of that shop, we can find out our targeted element or our targeted address. That is the similar to XPath access. So in XPath access, we can write the XPath by using some XPath access keywords which can associate with some specific element location. So that will be using context of some another element to find out our targeted element location. And it is very useful when target elements do not have any unique attributes or a static inner HTML. Then we need to locate the elements with respect to an element who has an unchanging XPath. XPath has 13 different axes, or we can say XPath has 13 different keywords, those which we can use in our XPath. But we will not look into all of them. We will just check out subset of useful axes which are most commonly used with Selenium. We will see 8 such XPath axes or keywords that are very useful in XPath access to find out the web elements. And whenever we use the XPath access, our target element should be closer to known element, or it is known as a context element, to make XPath shorter and readable. For example, these are the 8 keywords or XPath axes that we will see. What are these keywords now? So child, parent, following, preceding, following sibling, preceding sibling, ancestor and descendant. So these are the 8 XPath axes. We will look into it. Now let's see what exactly are XPath axes and what is the relationship of the nodes and what is the meaning of all these keywords. So in this session we will see only the concept, and in the coming session we will see about the syntax and practical example about XPath axes. So now let's understand the concept now. Imagine this is a DOM structure in which elements are referenced by the nodes, right? So every circle is basically a node, or we can consider it as an element in our DOM structure. It is a tree structure, right? So there is root node and child nodes. Out of these nodes, we have to consider anyone as a self node or context node. Now in this, let's say I am considering one node as a context node, and by using this context node we can find out various nodes location by using XPath access. Now how they are related to each other? So first is child. First one we will see is a child XPath access. So if you see this node, for this self node, what are the child nodes? If you see these two, now this one and this one. Just a second, I am just making okay, so this is the self node or the context node. So we can consider any node as a self node. So this is, in this example I am considering this node as a self node. Then this one and this one, these are the child of this self node. These two are child of this self node. And if you consider a parent node, so immediate top, so self node's immediate top node is the parent node. So if you see, this is the parent of this self node, and there are two child for this self node. So that is the relationship with the context of this self node. So there is one parent, and these two nodes are basically child of this self node. Immediate top is a parent node, because we have considered this node as a self node, and the nodes we are descending from this self node are basically child nodes. Immediate descendants are basically child nodes. If you see from this self node, there are two child nodes, immediate descendants. Now what are the ancestor? Ancestors are parent of parents. If you see, this is the parent node. Parent also included in ancestor along with the parent. So every node, self node, can have only one parent, and parent of parent are basically ancestors. Now this one and this one are ancestor node of this self node. This 1, 2, 3, all three are considered as a ancestor nodes for this self node, whereas this single node is a immediate top node is parent node. Similarly, there are descendants as well. So child node and children of child are also considered as a descendant nodes. So this self node having two child nodes which are also considered as a descendant nodes, and children of child are also the descendant nodes. So this self node has two child node and overall 6 descendant nodes. So that's about the self, parent, ancestor, child node and descendant nodes. So let's revise one more time. Self is the context node itself. Self node is a context node itself. If you see this node, this is a self node. That means itself is a context node. That's why it is a self node. Next one is child. All immediate children of the context node. All the immediate children, that means this one and this one, all the immediate node are basically child node. Parent node, immediate parent of the context node. Now what is the immediate parent? This node is the immediate parent. This is the immediate parent, it is a parent node. Ancestor, the parent of the context node, its parent, and so on until the root node is reached. All these are ancestor. Ancestor of the root node is empty node set. If you see here, this is the self node, its parent, parent of parent, that is grandparents, and its parent are basically all these three nodes are ancestor nodes. Descendant node are nothing but all children, grandchildren and so forth. So this self node is having two child. After that, child of child means all these are descendant nodes. Next one is following node. So what exactly are following nodes? All elements or the nodes in the document that occur after the context node are known as following nodes. All the elements in the document that occur after the context node except descendants of the context node, right? So descendant of the context node are not included. So apart from descendants of the context node, all the element nodes which are after the context node are comes under the following nodes. If you see the example here or the diagram here, in actual HTML, these nodes will be coming after the self node or the context node. So the nodes which comes after the context node are basically comes under the following nodes. The node which comes after the context node are basically following node, but it does not include descendant of the context node. Excluding descendant of the context node, whatever nodes are coming after the self node or context node are comes under following node. And what are the preceding nodes then? The nodes which are present before the self node are basically preceding nodes, excluding the ancestor node. Excluding this ancestor node, whatever nodes are present after the self node, after the self or context node, these are basically all preceding nodes. All the nodes in the document that occur before the context node except for ancestors are basically preceding. The nodes which are after the self node are following nodes, excluding the ancestors. All the nodes in the document that occur before the context node except ancestor are preceding, and all nodes in the document that occur before the context node and have the same parent. So following is all elements in the document that occur after the context node, and excluding the descendant are following. All nodes in the document that occur before the context node except for ancestor are preceding. Let's revise one more time. So all the node after the self node are considered as a following, excluding the descendant one. Nodes coming after the context node are following, and all nodes in the document that occur before the context node. So if you see whatever on the left side here, in DOM structure, what will happen? In DOM structure, this will be before the self node. That's why they are preceding nodes, excluding the ancestor. And if you see the DOM structure, the following nodes will come after the self node, excluding the descendants. Similarly, there are following sibling and preceding sibling. So following sibling are the nodes which comes under the following. That means they are after the self node and having the same parent. The element or nodes which comes after they are basically after the context node comes under the following, and they have the same parent node. If you see this, they are having this one and this one. These two nodes are basically following nodes because they have the same parent as a context node, and they comes after this self node. And what are the preceding sibling? Nodes are the nodes which coming before the context node, and having the same parent. So this one and this one, these two nodes are having the same parent as a self node, and they are coming before the self node. That's why they are preceding sibling. So that is basically preceding sibling and following sibling, right? So we have seen following sibling and preceding sibling. In HTML DOM structure, let's say one more example. In HTML DOM structure, let's say these are all the different nodes. So basically company is a root node or the ancestor node in the context of this department node. Let's say I am taking this department node as a context node. Now here if you see, this department node is a context node, and if you see the hierarchy, this department node, this department node, this department node, and this department node, these 1, 2, 3 and 4, these are all coming from this parent axis, that is division node. So this department is a child of division. This department node is child of this division. That means division node is parent of this department. This division node, if you see the relation of this division node, let's say I want to find out location of this division node, but this division node is not having any unique attribute, but we know this is the context node. This department web element have some attribute via which we can locate this department node. If I know the XPATH of this department node via some unique attribute, if I know the department XPATH, then I can use this relation. So I know that this division node is a parent of this department node. So by using that relationship of parent and child, I can simply find out XPATH by using XPATH access for this division node, because this is the parent of department node. We will see syntax in our coming session, but just understand the concept that this division node is a parent of this context node. So this is the relation. So we can use that relation in our XPath and we can find out location of this division node because it is a parent of department node. Similarly, if you see this team node, now this team is an immediate child of department node. So department node is our context node, or we can also call it as a self axis or self node. And this team node, and if let's say this team node is not having any unique attribute, and I want to find out this team node or team element. So this, I know this is a immediate child of this department node. This team is an immediate child of this department node. So I can find out that by using the context of child, right? So this team is a child of department node. That is the context node. And if you see, what are the children of this child? So department is having team as a child node, and this employee, these two nodes, employee nodes, are basically child of team node. That means it becomes descendant node for this department, right? So we have seen the example, children of child, including child, all of them are basically descendant node of department. So if I use that relationship of descendant with the context of this self node, then this team, employee and employee, these three are descendant node for this department. And similarly, if you see this department and this department, these two nodes are having the same parent and they are coming after this department node. We have also seen, right? So elements or node which comes after the context node and having the same parent are basically following sibling nodes. These are following sibling because they are on the same level, they are basically child of same parent and they are coming after the context node. That's why these two nodes are basically following sibling axis node. These are two following sibling axis. And this department, if you see this department, it is coming before this department having the same parent. So this department is a preceding sibling. This department node is a preceding sibling of this context node. And if you see this company and this division, they are parent of this department. So division is an immediate parent, whereas company is a parent of division. That means these two nodes are ancestor node for this department node. These two, that is company and division, these two nodes are ancestor axis for this department node. So this is how we can use the relationship or XPATH access with context of self node or context node. So this is the simple concept understanding for XPATH access. So by using XPATH access, let's revise one more time. So what exactly are XPATH access are? They provides a way to navigate and select elements in a XML or a HTML document using a specific relationship with other elements. They help you find out element based on their position or association with other elements. Think of access as a different direction or perspectives we can use to search for elements. So by using this XPath access keyword, we can navigate through DOM structure using context of some another element. We can traverse from to top, we can traverse via bottom by using context of that element. So there are total 13 different XPath access, but we will look into 8 subset of useful access which can be used with Selenium, which includes child, parent, following, preceding, following sibling, preceding sibling, ancestor and descendant. We have also seen the example. So the nodes, so if you consider this as a self node, then immediate top node is a parent node, immediate children are child nodes, parent of parents including the parent are ancestor nodes, child and their children's all comes under the descendant node, elements which comes after the context node but excluding the descendant are following nodes, elements which comes before the context node but excluding the ancestor are known as a preceding nodes. There are following sibling nodes which are having the same level, having the same parent but coming after the context node are basically following sibling, and the elements or nodes which comes before the context node and having the same parent are preceding sibling node. So that's the understanding of different type of XPath access. So this is the concept. We have also seen the example how we can use different type of context. For example, if department is a context node, then its team is a child node, team employee, these three nodes are descendant node. This one which comes after this department node but having the same parent as a division are following sibling nodes. Division is a parent node for this department node, and company and division both are ancestor node for this department node, and this department is preceding sibling node. In coming session we will see about the syntax to write this XPath access and practical examples how we can write the XPath access to locate the web elements in Selenium. So thank you for watching this video, guys.